This video is to review the difference between definition of midpoint, segment addition postulate, and definition of angle bisector and angle addition postulate. So if I were to tell you that point B is somewhere on line segment AC, what is the only statement that you could write that's true about this? A statement that has an equal sign, so an equation. I'll give you a minute to think about it. You should write down the equation on your own for practice. Okay, so that statement would be line segment AB plus line segment BC is equal to line segment AC. And that is called the segment addition postulate. You can think of it as small segment plus small segment equals big segment. I'm just going to make up these algebraic values. Suppose AB is x plus 3 and BC is 2x minus 6 and AC has a length of 104. So if I was to give you that on a test or quiz, as I have done, you should label the information in the diagram and then make the equation. So small segment plus small segment equals large segment, or big segment. You can then solve for x, which I'm not going to do, and then solve the rest of the problems. If I asked you to find what AB is, then you would just insert the value of x here into AB. You should check to make sure when you insert the value of x into BC that when you add AB and BC together, you get the entire length, which is 104. Okay, moving on. Now suppose, though, I tell you that on line segment RT, some point, I'll call it M, is in the midpoint. Well, think if M is in the midpoint of line segment RT, what equation would be true? Give you a minute to think. You should write it down. So what is a midpoint? Since a midpoint is a point that divides a segment into two equal pieces, you can mark your diagram as little segment RM equals little segment MT, and that's by definition of midpoint. What's also true if we have a midpoint is you could say two of the small pieces, so two of either RM or 2MT equals one big piece, RT. Or you could divide by 2 and say one of the small piece, I'll use the other small piece, MT, equals 1/2 of the large piece, RT. So as before, if I gave you information, for example, if I gave you RM was x minus 4, and if I gave you that RT, the entire piece, is 36, what could your equation be? Well, realize if little segment RM is x minus 4, couldn't you call big segment MT also x minus 4? And you could add and say x minus 4 plus x minus 4 equals 36, or you could take two of the small pieces, which would be 2x minus 4, would also be equal to 36. This for angle bisector and for definition of angle bisector. So, by the same token, if you have some angle ABC, and there's some ray BV somewhere in the interior of angle ABC, but not an angle bisector, what equation could you come up with? Well, I'm going to call the top little angle angle 1, and the bottom angle is angle 2. So think what equation you could do. You should write the equation down to practice. Well, the equation I'm going to think of is small angle plus small angle equals large angle, which would be angle ABC. And that's going to be true by the angle addition postulate. But now let's suppose that ray BV bisects big angle ABC. Think what equation would now be true if this was the case. So I'm going to just erase my ray, and now I'm going to put another ray more what looks like in the middle. BV, I'm going to call it angle 1 and angle 2 again. So the top equation is still going to be true, even if it's an angle bisector. Small angle 1 plus small angle 2 is still going to equal large angle ABC. But if BV bisects angle ABC, a bisector is similar to a midpoint. In this case, instead of having two equal segments, we have two equal angles. So the equation you can think of would be angle 1 equals angle 2. And that's by definition of angle bisector. As before, you could also say 2 times either small angle. So for example, 2 times angle 1 is equal to the measure of angle ABC. Sorry, I kind of squished that over. Let me erase that. Not a lot of room. So you could say 2 angle 1s equals angle ABC, or 2 angle 2s equal ABC, or as before, you could take either angle of either one of the small angles and say it's equal to 1/2 the large angle. Please review this. That would be angle ABC. Please review this and make sure, if you have any questions, you see me at office hours or go to the math lab during your free period.